Hi, today's topic is telescopes. First, let's talk a little bit about the history of the telescope. Hans Lippershey was the first one to invent the telescope in 1608, and he invented the simple refractor telescope. A lot of people think that Galileo was the first to invent the telescope, but he didn't invent it, he was just the first to use it in astronomy. And he did take this basic design and expand on it a little bit with a combination of convex and concave lenses to specifically use it in astronomy. Johann Kepler then later improved this design, and his design is still the major one that's used out in refracting telescopes today. Optical telescopes are the type that observe visible light, what it is that we actually see with our eyes. And there are two main types. There are refracting and reflecting. And you can see from the picture here that the refracting telescope has lenses, and the reflecting telescope uses mirrors. There are two main properties that we look at with telescopes. One is how well it collects the light, which is called the aperture, and the other is how much it can magnify the image, which is called the magnification. A telescope's ability to collect light is directly related to the diameter or the size of the lens or mirror that it's using to gather the light, and so aperture really depends on the size of this. Generally, the larger the aperture, the more light that the telescope collects and brings into focus, and the brighter the final image. Now, magnification is just the ability to enlarge an image, and it's really the eyepiece that performs the magnification, and since any magnification can be achieved by just changing eyepieces, aperture ends up being a more important feature than magnification. The refracting telescope is a type that uses lenses to gather and focus light, and they typically have the following parts: a very long tube made of metal, plastic, or wood, a glass combination lens at the front end, and a second one at the other end, which is the eyepiece. Refracting telescopes focus light rays by bending them with glass. This is the simplest telescope design that you can have. A big lens gathers light at the front opening here, right at the front here, the incoming light, and it directs it to a focal point, and then the small lens brings the image to your eye. Now, refracting telescopes do have a few drawbacks. One is that in order to be a good telescope and to gather a lot of light, they have to be very, very large. And because we're talking about lenses here, the larger the lens, the heavier it is. And so they can be very, very heavy and unwieldy. They're not good telescopes to carry around with you because they can be so heavy. And then also, the larger the lenses, the bigger the distortion. And then also, these large lenses can be very expensive. A reflecting telescope uses a curved mirror to gather and focus light. So you can see at the front end here, this is where the incoming light comes in, and it goes all the way to the end where it bounces off the primary mirror, back off the secondary mirror, and in through the eyepiece. The advantages of reflecting telescopes is that the mirrors can be very large, and even when they are large, if there's any flaws in the glass, it's not going to affect the light at all. And mirrors can focus all colors of light into the same focal point, which refracting telescopes cannot do. Lenses actually divide the light up a little bit, and so they can cause some aberration or different colors to focus in differently, but reflecting telescopes don't have that problem. There are some important optical telescopes that you've probably heard of before. One is the Hubble Space Telescope, and this is out in space, and then the other are the Keck telescopes in Hawaii. And so one of these is in space, and one is on the top of a mountain in Hawaii. And there are some big advantages to having the Hubble Space Telescope out in space because you don't have to worry about the atmosphere getting in the way and distorting your image at all. There are other types of telescopes that are used besides ones that just look at visible light. Many modern-day telescopes do not use visible light and use other wavelengths. This here is the electromagnetic spectrum, and this shows all of the different wavelengths that energy is given off in, and you can see that visible light is just this small section right in here, and you can see kind of the colors of the rainbow here, all the different spectra. But if we look on both sides there, we see that the things to the left are much shorter wavelengths: gamma rays, X-rays, and ultraviolet rays. And then to the right we have the longer wavelengths: infrared, radar, and radio waves. Radio telescopes, X-ray telescopes, and infrared telescopes have really become a staple of modern-day astronomy, and we'll be looking at a lot of different images in this course that are from those different wavelengths. Radio telescopes obviously detect radio waves. They have to be a lot larger than optical telescopes, though, because the wavelengths are so much longer. It has to be a lot larger to capture those. But they do not have to be as flawless. They can have some flaws in them, and it doesn't really affect the gathering ability. X-ray telescopes, like the Chandra X-ray Observatory, are much more sensitive than optical telescopes and can take in a lot more information. And we see most of these telescopes in space, because most electromagnetic waves besides visible light can be blocked by Earth's atmosphere, so we find most of these telescopes in space.
Dear Tim and Moby, how does a telescope let you see things far away? From Eugenie. The moon is about a quarter the size of the Earth. But because it's so far away, it looks pretty small. We can see it because light reflected off of it focuses a small spot of light on your eye's retina. From where we stand, it just looks like a little glowing yellowish white circle. With a good enough telescope, you can see much more detail, craters and mountains and stuff. Telescopes capture and magnify light. As you can see in this simple telescope, a large lens in the opening collects the light bouncing off of a faraway object and focuses it at a point inside the body of the telescope. Then a smaller lens in the telescope's eyepiece magnifies that focused light and projects it into your eye. Since the light has been magnified, the image takes up much more of your eye's retina, and you see more detail. That's a refractor telescope, one that uses glass lenses to gather light. There's another kind, a reflector telescope, which uses a series of curved mirrors to gather and focus light. Light comes through the opening and is reflected by a curved mirror onto a second mirror, which reflects the light into your eye. Some telescopes are better at collecting light than others. The aperture of a telescope is the diameter of the lens or mirror that gathers light. The larger the aperture, the more light the telescope can focus, and the brighter the final image. Magnification is the telescope's ability to enlarge an image. Magnification is handled by the eyepiece, and it depends on the combination of lenses used. Well, no, there are many different types of telescopes. Optical telescopes include the simple handheld ones that pirates use, and binoculars, which are really just two telescopes stuck together so you can see in stereo. There are also giant telescopes like the Keck Observatory in Hawaii, and the Hubble Space Telescope, which operates from Earth orbit, where its images can be free of the distorting effects of Earth's atmosphere. All optical telescopes magnify visible light, so it's stuff you can see with the human eye. But there are other important types of telescopes that see in other kinds of electromagnetic radiation. Radio telescopes see in radio waves. Radio telescopes can be used alone or together with other radio telescopes to study things like stars and other really distant space objects. They're also used to collect data from satellites and space probes. Other telescopes collect things like X-rays, gamma rays, and infrared light, mostly from stuff that we just can't see with visible light. Hey, be careful. Oh!
So hopefully that brain pop reviewed what I talked about in the video today, and that's it on telescopes.